Welcome to Maths and Science by IITIAN channel. In this lecture, I will be taking up a very good example or a practice question in physics for JEE Mains, JEE Advanced and NEET Physics. It is in the topic on mechanics. The subtopic is friction, in which in a bigger hollow sphere, a small spherical sphere is rolling. Now, what we have to find out is, if the small sphere, solid sphere is from the rest at an angle theta naught is released, what happens to it? Small sphere, does it lose contact with the surface of the bigger hollow sphere or not? Second, we have to find out the velocity at an angle theta, at any angle theta of the solid sphere inside the hollow sphere, and what is the normal reaction, and what is the minimum coefficient of friction that is required so that slipping is avoided. Slipping is avoided. Slipping avoided. It's a very good example. It is full of concepts on friction, rolling, motion. To avoid the slipping, what is the minimum friction required, and how the normal force is calculated, and how the velocity at any angle theta is calculated. It involves the concepts of the potential energy and the kinetic energy. These are all the things clubbed in this, combined in this particular example or a practical question, so that you will understand the concept of the friction, and any type of these questions are asked in the examination, you will be able to solve them if the concepts are very clear. Now, let us move further to solve this question. This question is a very useful question on friction involving many concepts, and the question is, already the diagram is given. At an angle theta naught, initial angle, the small sphere is left from rest. What happens to it? Bigger sphere, hollow sphere, radius is, it is given as capital R, and smaller solid sphere, radius is equal to smaller initial angle at which the small sphere left from rest is equal to theta naught from the lowest point vertical axis, and from this data, what we are supposed to find out are velocity of the sphere at an angle theta. First one is velocity of small sphere at any angle theta. Initial angle is theta naught. What will be the velocity at any angle theta? Normal reaction. We have to find the normal reaction. And minimum coefficient of friction required, mu minimum is equal to how much? For avoiding slipping, only rolling. Rolling without slipping is avoiding slipping. Rolling without slipping. This is rolling without slipping. Now, fourth question is, it's a very big problem. It's a practice problem. Please practice it so that you will understand the concepts of the friction very well. Whether small sphere loses contact with hollow sphere. These are the questions which we have to answer. Let us try to answer one by one by understanding each concept clearly. Let's move further. Let us go for the solution, step by step solution. Now, let us try to understand the geometry. Let us try to understand the geometry first. Let us define some geometric parameters. We will understand the geometry. And let there be small sphere with radius r. Small sphere radius is r, capital sphere radius is capital R. Then from the point of view of center of mass, let this angle be theta naught. What happens when this particular sphere comes here in this position? Because it is not slipping, it is rolling. Let us assume that it is still in the contact with the whole sphere. Now, this is the path of COM, center of mass of small solid sphere. This blue line is the path of the center of mass of small sphere. Are you able to understand? Any doubts? Please ask in the comment column. Now, let us do everything, all calculations, whether energy calculations or velocity calculations, everything with respect to COM. Radius of path of COM will be, what is the radius of COM? This is r minus r. Small r is the radius of the small sphere and big R is the, capital R is the radius of the whole sphere. Then r minus r is the radius. the distance from the center of the holosphere to the COM. Instead of calling it as radius of path of COM, we can even call it as distance of COM from center of holosphere is equal to, this is called as OC. Let us COM be called as OC. OC is equal to R minus R. Because we are doing all the calculations with respect to COM of the small sphere, small solid sphere. Now, for an angle of R minus R, let us consider for an angle of theta naught, this let us see, this we will call it as D. What is the OD value? I have told you many times in my previous lectures, please see them. The distance between points in a triangle, right angle triangle, adjacent to the angle will be, OD will be OC into cos theta naught, if angle is theta naught, where initial angle with respect to the vertical axis is theta naught. What is OC? OC is nothing but R minus R. Therefore, OD is equal to R minus R into cos theta naught. Now, if center of mass is taken as the reference line, now let me draw the reference line here in green color. This is my reference line for all calculations. Please pay attention to it. For all calculations, reference line. Then, at theta naught, the height. For calculating the potential energy, we require the height. At theta naught, let initial height be h naught. H naught is equal to initial height of COM. From reference line. Reference line is COM at lowest point. This is C dash, this is C double dash. OC is R minus R when we consider theta naught. H naught is equal to initial height of COM from reference line. Actually, when you calculate the from the bottom, sorry, let us draw it clearly. Another diagram I will explain. This is very important. Hence I am explaining again and again. This is theta naught and this distance is R minus R cos theta naught, and this is the COM, let us say. we require this distance, not from the bottom. We have to calculate from the COM because we have taken reference line as COM. This is the reference line. From reference line, we have to find this height. Potential energy is always height with reference to a reference line. Potential energy cannot be absolutely found out. It is the difference with reference to the reference line. If reference line is taken as 0, then from that reference line, what is the height we are measuring? That is going to be your difference in potential energy or potential energy. Now, what is H naught? H naught is equal to this total distance is R, and from reference line this distance is R minus R. Please try to understand this. This is R because COM is taken as the reference line, and here this is the sphere at the lowest point. This is R. Now, what will be H naught? H naught will be R minus R minus R minus R. This H naught will be R minus R minus R minus R into cos theta naught. Please try to understand this. This is the most crucial step in this problem, solving this problem. That gives you H naught is equal to R minus R into 1 minus cos theta naught. If theta naught is replaced by theta, general theta, at any angle theta, at any angle theta, H is equal to R minus R into 1 minus cos theta. Because ultimately we are interested in calculating at any angle theta. This is one of the important equations we have got here. Now, for the purpose of energy, conservation of energy at any angle theta, what is the initial values? Initial values are velocity V naught is equal to 0. Initial velocity is 0 because it is moving from the rest. And angle is equal to theta naught. Initial angle is theta naught. And what is H naught? H naught is equal to R minus R into 1 minus cos theta naught. What is the initial potential energy? Initial potential energy is equal to R minus R into 1 minus cos theta naught, and initial kinetic energy is equal to 0 because initial velocity is equal to 0. Now, potential energy should be mgh. There should be some mg. That means initial potential energy is equal to mg into r minus r into 1 minus cos theta naught, and initial kinetic energy is equal to 0. What is the final potential energy? Final potential energy is equal to, at angle theta, mg into r minus r into 1 minus cos theta. And what is the final kinetic energy? Final kinetic energy, it will be translation and also rotational. Translational, please, it is very important, plus rotational. That gives you half mv final square. Because initial velocity is 0, final velocity, even if you call it as v, there is no problem, plus I into omega square, half I into omega square, kinetic energy final. And delta Ke, now from these, all these, what we get? Delta Pa, change in potential energy, is equal to mg into r minus r into 1 minus cos theta final minus initial, mg into r minus r into 1 minus cos theta naught. Sorry, cos theta naught. And what is the change in kinetic energy? Delta Ke is equal to half mv square plus what is the moment of inertia? I for a solid sphere, half into 2 by 5 into mr square into omega square, since I for a solid sphere is equal to 2 by 5 mr square. These values I have calculated and proved in my previous lectures. Please refer to them for any clarification. Now, tell me, what is the change in potential energy? Mg into r minus r into 1 minus cos theta minus 1 plus cos theta naught. And what will be change in kinetic energy? Here we are only writing the changes. Don't worry about plus minus. Mg into r minus r into cos theta naught minus cos theta. If cos theta naught is greater than theta, cos theta, then it will be positive. Kinetic energy is equal to half mv square. This 2 into 2 and 2 get cancelled. 1 by 5 into mv square. Why? Omega square r square is equal to v square. Since v is equal to omega r. This is from the basics of the rotational mechanics. Now, what will be the value? Delta Ke is equal to mv square into 1 by 2 plus 1 by 5, that is equal to 7 by 10 into mv square. What is the change in potential energy? Even cos theta naught minus cos theta, we can even write it as cos theta minus cos theta naught, because it is a difference only. We are getting v square only from this. Now, we can write it as mg into r minus r into, if cos theta is greater than cos theta naught, then cos theta minus cos theta naught. Then, from the above two, we will get, because from the conservation of energy principle, conservation of energy, what it says, neither energy can be created nor energy can be destroyed. Delta PE is equal to delta KE. Please remember this. From this principle, what we get is that mg into r minus r into cos theta minus cos theta naught is equal to 7 by 10 into mv square. That implies v square is equal to 10 by 7 into get cancelled on both sides. R minus R into cos theta minus cos theta naught, and this is what is required to be proved. We have proved it. Now the velocity is equal to velocity of that particular solid sphere at any angle theta will be 10 by 7 into r minus r into cos theta minus cos theta naught square root. This is the value, velocity. Now we got the value of velocity from the energy principle. Now we have to find out the normal reaction. You just see what we have to find out from the problem. Just see here. Velocity, now we have found. Now normal reaction we have to find. This is the normal reaction. N is equal to, we have to prove mg by 7 into 17 cos theta by 10 cos theta naught minus. Now what is a normal reaction? Let us try to move. Normal reaction is inward towards the center of the whole sphere. You see, here small sphere, and here it is the center of the whole sphere, and this is towards it. This is normal reaction. For finding the normal reaction, the component of the weight acting towards the center of the earth or acting downwards should be found out. And this angle is theta. This type of problems, I have solved many problems. How to resolve the components, force components. Please try to refer to my earlier lectures for this. This angle is theta. And this will be mg cos theta, because any theta near to the theta component is mg cos theta. N is in the upward direction, mg cos theta is in the downward direction. Therefore, the net force will be n minus mg cos theta is equal to mv square by radius, effective radius. mv square by effective radius. This is the centripetal force. The force is towards the center. To counter that, centripetal force is required in this direction. That centripetal force is m square by r, effective r. What is the effective r? R effective is equal to, from the beginning we are telling that we are doing it with respect to the COM of the small sphere. R effective is equal to r minus r. Then it will be n minus mg cos theta is equal to mv square by r minus r. And we know the value of v square, 10 by 7 into r minus r into cos theta minus cos theta naught. That implies n minus mg cos theta is equal to m into 10 by 7 into r minus r into cos theta minus cos theta naught whole divided by r minus r. R minus r and r minus r get cancelled. Then we will be left with the equation n minus mg cos theta is equal to 10 by 7 into m into, it is v square is g is there, g is there. Sorry, I have forgotten g. We will write g here. M, g will also be there. mg, 10 by 7 into mg into cos theta minus cos theta naught. That implies normal force N is equal to mg into cos theta plus 10 by 7 into cos theta minus cos theta naught. That implies N is equal to mg by 7 into 7 cos theta plus 10 cos theta is 17. 17 cos theta minus 10 cos theta naught. This is how this problem is to be solved. Even though it looks lengthy, the steps are simple and you can understand well. Once you understand the concepts, you will be able to do this type of questions very easily. This is the answer, it is proved as given in the question. Now, what is next we have to find out? Frictional force. Once we get the frictional force, from that we can find out the minimum friction required. For minimum friction, friction factor, you call it as friction coefficient. To find this, we have to find the frictional force. What is the frictional force? Frictional force acts against the motion of the body. What is the motion of the body? The body wants to move downwards because of the gravitational pull. I am drawing only part of it. Because of this gravitational pull, it wants to come this way, pulling down. And when this force is mg cos theta, because this is theta, a force at 90 degrees angle will be mg sin theta. Rather, it is not mg sin theta. This is mg sin theta. And opposite to mg sin theta is the frictional force. And net force is in this movement downwards. Then this net force will be m into at, acceleration. Now, what is the final equation we get? It is moving downwards. Mg sin theta is dominant. Mg sin theta minus some friction, frictional force is acting in the opposite direction of the motion, and the body is moving downwards with an acceleration at. Here, at can be calculated as r into alpha. Rotational acceleration. It's a rotational motion. This also please remember. The translational acceleration is equal to r into rotational acceleration. Translational velocity is equal to r into angular velocity, or rotational velocity, angular velocity. It is angular acceleration, r alpha. At is equal to r alpha. From this, what we get is that mg sin theta minus frictional force is equal to mr alpha. From basics of mechanics, frictional force into radius is equal to moment of inertia into angular acceleration. Please remember this equation. We will substitute these values here. What happens? From this, we get mg sin theta minus Fr is I alpha. F is I alpha by R is equal to m into R alpha. What is R alpha? At. In terms of At, we will write mg sin theta minus alpha by R is equal to, alpha by R will be At by R square. Alpha by R is equal to At by R square. These are all simple substitutions, that's all. Mg sin theta minus, you have to understand the main concept. This equation, this is the most important equation. Mg sin theta minus frictional force is I alpha by R is nothing but, sorry, we will write in the black ink, I into At by R square is equal to mr alpha. I into At by R square is equal to m r alpha, that is m into At. That means I is, what is the value of I? 2 by 5 mr square. Let us convert everything into m. Mg sin theta minus 2 by 5 mr square into At whole divided by R square is equal to m into At. Now we will cancel m here. R square we will cancel. At is equal to g sin theta minus 2 by 5. At is equal to g sin theta minus 2 by 5 At. Bringing At on one side, we will get 7 by 5 At is equal to tangential acceleration, translational, tangential, g sin theta. That implies At is equal to 5 by 7 into g sin theta. This is what is, we got the acceleration of the body. Are you able to understand this? This is the holosphere, this is the solid sphere, and this is mg, this is mg sin theta, this is frictional force F, and the whole system is moving with m a t, and this at value here, whatever this at value that we have found, the whole system is moving with a acceleration of 5 by 7 g sin theta. Now, the whole system acceleration. Then, You just see. Then what is the frictional force? Frictional force we can calculate. What is the frictional force? mg sin theta minus F is equal to MAT. mg sin theta, when you resolve the forces, mg sin theta minus F is equal to MAT. You got the value of AT as 5 by 7 g sin theta. M into 5 by 7 g sin theta. From this what we get? F is equal to mg sin theta minus mg into 5 by 7 sin theta. That implies the frictional force is equal to 2 by 7 mg sin theta. This is equal to 2 by 7 mg sin theta. Now, we got the total values with us. Now we have to find out the minimum coefficient of friction. This force is nothing but mu into n, frictional force. We know that frictional force should be less than or equal to mu into n. Because we have to find out the coefficient of friction. That is, mu should be greater than or equal to F by n. Now we got the value of F, we got the value of n, then we'll get mu should be greater than or equal to, what is F? 2 by 7 mg sin theta, 2 by 7 mg sin theta whole divided by, what is the value of n? We have got the value of n as mg by 7, 17 cos theta minus 10 cos theta naught. mg by 7 into 17 cos theta minus 10 cos theta naught. Now, you cancel mg here and 7 here. Then that will be 2 sin theta by 17 cos theta minus 10 cos theta naught. Mu, the friction factor should be greater than or equal to 2 sin theta whole divided by 17 cos theta minus 10 cos theta naught. That means mu minimum is equal to occurs when theta is equal to theta naught. That means mu minimum is equal to 2 sin theta, 2 sin theta naught divided by 17 cos theta naught minus 10 cos theta naught. That is equal to 2 by 7 into sin theta naught by cos theta naught. That implies mu minimum is equal to 2 by 7 into tan theta naught. That minimum friction coefficient is required for rolling without slipping is, in this case, mu minimum is equal to 2 by 7 into tan theta naught. Now, the final question is whether this small sphere lose the contact with the bigger sphere. Question is to check whether small solid sphere loses contact with bigger hollow sphere. Loss of contact will take place when normal force is equal to 0. Loss of contact takes place. Why it takes place? When n is equal to 0. Because n is towards the center. Losing contact inside the hollow sphere means the small sphere moving towards the center. Losing contact means the small sphere is moving towards the center. When n is equal to 0, it loses contact. Mg sin theta, mg cos theta, and then n. When the normal reaction drops to 0, then it loses contact with the surface. Loses contact means it's not coming inside, rather we can say it is going out. Even we can say. Let's imagine this also. Can it go out? When n is less than or equal to 0. We'll take the condition of n is equal to 0. Then 17 cos theta minus 10 cos theta naught is equal to 0. That implies cos theta is equal to 10 by 17 into cos theta naught. When it will be possible? When cos theta is greater than cos theta naught. For regular cos theta, if the initial condition at rest is equal to cos theta naught, cos theta naught cannot be lesser than cos theta. Never happens. That means sphere never detaches from surface of the hollow sphere. Small sphere. This is also proved. That means all the values are proved in this. This is a very good example on rotational mechanics plus rolling constant problem. rotational mechanics plus rolling constraints. It's a very good problem. Please try to see it one or two times. If couldn't understand anything, please write to me in the comments column. I'll reply. And with this, I want to conclude this lecture. If you feel there is a value addition to you because of this lecture to you and will be useful in your examinations, then please hype this lecture. Then share this lecture and my channel details to known people and subscribe to my channel Maths and Science by IITIAN. Once you subscribe and encourage me, I will be able to give this type of questions to you regularly so that your concepts will be refreshed. And in the examination, you will not face much problem once your concepts are clear. Best of luck to everybody. Thank you for listening to me. Thank you for viewing my lecture. Best of luck.